An expandable balloon contains 2.10 cubic decimeter of helium at 81.1 kilopascal and 25 degrees Celsius. What volume will the balloon occupy when the pressure drops to 50.7 kilopascal and the temperature is 20 degrees Celsius? To solve this problem, we will use the combined gas laws. The formula for combined gas laws is P1 V1 over T1 is equal to P2 V2 over T2. Okay, so let's check the given numbers in the problem. 2.10 dm cube is the initial volume of the balloon, or this is V1. 8.1 kilopascal is the initial pressure, so this is P1. 25 degrees Celsius is the initial temperature, so this is T1. 50.7 kilopascal is the final pressure, this is P2, and 20 degrees Celsius is the final temperature, so this is T2. What is asked in the problem is the final volume. So V2 is missing. So we will derive an equation to solve for V2. If you do cross multiplication, your equation would become P1 V1 T2 is equal to P2 V2 T1. To solve for V2, you divide both sides by P2 T1. So P2 and T1 would cancel on the right side, and you're left with V2. So our equation becomes V2 is equal to P1 V1 T2 divided by P2 T1. So according to the problem, P1 is equal to 81.1 kilopascal. V1 is 2.10 dm cube. And T2 is 20 degrees Celsius. So don't forget that when you are using gas laws, you need to convert degrees Celsius into Kelvin. So you need to add 273.15. So 20.0 plus 273.15, this is equal to 293.15 Kelvin. So don't forget to convert your temperatures into Kelvin. So T2 is 293.15 Kelvin. And for the denominator, we have P2. According to the problem, P2 is 50.7 kilopascal. And T1, according to the problem, is 25 degrees Celsius. Again, you need to convert that into Kelvin. So 25.0 plus 273.15, that is 298.15 Kelvin. So T1 is 298.15 Kelvin. So if we check the units, kilopascal would cancel, Kelvin would cancel, and the unit for volume is dm cubed. So if we solve for V2, this is equal to 3.30 dm cubed. And this is the answer to the question.